Hi guys, so in this video I want to do integration of odd and even powers of cot and cosec, right? So this is chapter 7.2. So in chapter 7.1 we did integration by parts, right? So this one here requires integration by parts. It's actually, so for odd powers of cosec and sec, those ones require chapter 7.1, which is integration by parts. So they are actually questions from chapter 7.1. The other three that I wrote are questions from chapter 7.2. So remember what I said? I said sine and cos work together. They have identities in common. If you derive the other, you get the other one. And then sec and tan. So for tan and sec is the same thing. So we said sine and cos. Tan and sec is the same thing. That's a pair that has the same, they have identities in common, they have derivatives in common and all that. So we also have cot and cosec, which is what we are focusing on today. So cot and cosec, they have an identity in common, which says 1 plus cot squared of x equals cosec squared of x. That's the identity we'll be interested in, and the form that we will mostly use it in is cosec squared minus 1 equals cot squared of x. So that's what we're interested in. So let us look at the integral of, let's start with the integral of cosec cot to the power 5 of x dx. So we have cot to the power 5 of x dx. So what we are going to do here using this identity is we are going to basically isolate a cot squared from this thing. That means we're going to change it to cot to the power 3 of x cot squared of x dx. The reason why we do this is we want to take advantage of that identity that I talked about above. So we want to change that cot squared x into cosec squared x minus 1. So it's cosec squared here. So what we're going to then have is the integral of cot cubed of x bracket, where we had cot squared, we're going to put cosec squared of x minus 1, and then we'll have our dx. Now we expand this bracket, right, by saying, basically putting in the multiplying the bracket with the integral sign, the cot cubed of x and the dx. What do we get if we do that? We are going to get the integral of, for the first one, this part, we get cot cubed of x cosec squared of x dx. Then we say minus, it's that negative sign over there. We will get, for the last part, the integral of cosec, sorry, of cot, right? So it's going to be cot cubed of x, and then we will have a dx. Basically, we will multiply it with the 1, so we get the cot cubed of x. So we now have something like this here. So what we're going to do next is we're going to, for this part, we will use u substitution. Let u equals, we're going to let u equals, cot x, right? Because we know its derivative will then give us minus cosec squared x, which is similar to what we have. That is cosec, but we will then isolate the cosec squared x dx. So we get du equals minus cosec squared of x dx. Since here we already have a cosec squared of x dx, we want to make a substitution for that. So we'll get rid of that negative sign there, we'll put it on that side. We now have all our terms for our substitution for this part. So what do we get? We get, okay, let's deal with this part as well, right? We know that we have the integral of cot cubed of x. There we'll also need that identity that we used. So, okay, let's leave it for now. Let's start here. So we're going to then have the integral of, we said we are replacing cot with u. We're going to have u cubed, right? Where we have cosec squared x dx, we'll put a minus du. So we're going to have something like this here. So if we add 1 to the power and divide by the resulting power, which is 4 in this case, we're going to have something like this. Then that's going to give us minus u, right, to the power 4. So it's minus u to the power 4 over 4, right? And that then gives us minus, since u is cot, we get cot to the power 4 of x over 4. So on this part, okay, so I've written that integral. I've basically just substituted. So let me just do that again. So it's the integral of cot x and a cosec squared x, a cot squared x that I isolated. So we have a cot squared of x dx. That cot squared of x, we're going to replace it with cosec squared x minus 1. So we're going to get cot x bracket cosec squared x minus 1 and then dx. We are then going to expand this bracket, right? We're going to expand that bracket. So we also had a negative sign here. That negative sign is this negative sign, right? So we are then going to keep it here and we'll multiply. So basically when we're done, we won't need to include it because we've taken care of it. So we are going to get here minus the integral of cosec cot squared. It's cot squared. Oh, it's cot actually. Cot x multiplied by cosec squared of x dx. And then for the other part, we'll have plus, because that negative and that negative will give us a positive. So we'll have plus the integral of cot x dx. So what we'll then do on this part, same thing that you substitution, but what you need to understand is that whenever you have a cot and you have cosec squared, you just need to have cosec squared, right? Your solution will resemble the kind of solution that you would get if you were integrating something like x squared. You would get x cubed over 3. So that means when you have cot x and a cosec squared, as long as there is a cosec squared next to it, you're going to just add 1 to the power. You get cot squared of x. So that's going to give you what? Let's do this. You're going to get cot squared of x, but you're going to then also need to put a negative. Remember, we also then got that negative, but here it will become a plus because we already have a negative outside. So we'll say over 2. Then we'll have plus the integral of cot x is cos x over sin x dx. There is a rule that says, let me write it down for you. So that rule says if the derivative of the denominator gives the numerator, then the integral of the fraction is ln of the denominator. So in this case, if you derive sine, which is your denominator, you get cos, which is your numerator. So your answer is ln of the modulus of sine x, right? So that means we can replace this part here with the ln of the modulus of sine x. So we now combine what we got here with what we got here. So we're going to get minus cot, so that's for the integral. The integral of cot to the power 5 of x dx gives us, so it gives us minus cot to the power 4 of x over 4 plus cot squared of x over 2 plus ln of sine x. And then we need to put a constant of integration c. So I'll just put it down here and say plus c. So that is our solution there. That is our solution. That is our solution. That is our solution. So I hope you guys understand.